Everyone, welcome to the Ultimate Python course. Whether you are a total beginner or looking to sharpen your skills, you have come to the right place. In this course, we will start with the basics, covering the history of Python, foundational concepts, and guide you step by step through file handling and object-oriented programming. But that's not all. We also explore powerful libraries like NumPy and Pandas, giving you the tools to tackle data manipulation and analysis. By the end of this course, you will have a good grasp and overview of Python. Without wasting time, let's embark on the journey of Python. Python is a high-level programming language created by Guida van Rossum and first released in the year 1991. What makes Python stand out is its readability and simplicity. There are two major versions of Python programming language, that is Python 2 series and the newer version Python 3 series. It is used in variety of fields like web development, data analytics, artificial intelligence, automation, and much more. With this, we have covered the introduction, and now let's move on to indentation. One of the key features of Python is its use of indentation to define the code block. Unlike many other languages use braces or keywords, Python uses indentation to show which line of code belongs together. In Python, indentation is mandatory. Let's take a look at this example. Here, the print statement is indented, indicating it is part of this if block. You can also look at this image. Here, the print statement is indented to show that it is part of this if block, and this print is indented to show that it is part of this else block. And the indentation is nothing but spaces. We generally give 4 spaces or a tab space to indicate that the lines of code belong to a specified block which is defined with a colon. If anyone is curious about what will happen if you don't follow these indentation rules in Python, it will raise an indentation error. Here in this example, this print statement lacks indentation, which will result in an indentation error. If you want, you can check this out. I hope this clarifies the indentation rules in Python. Next, we will move on to discussing comments in Python. Comments are essential for explaining what your code does, and they are ignored by Python interpreter while running the program. You can use these comments to make your code more readable. In Python, we have single line comments and multiple line comments. Single line comments start with hash, and you can see in this example how single line comment looks. If you need to explain your code in detail and it requires more than one line, you can use multiple line comments which start and end with triple quotes, as you can see in this example. In the place of this is a multiple line comment, you can write more than single line of comment. By this we have finished the comments, and now let's explore keywords in Python. Keywords are reserved words in Python that have a special meaning. Python has 35 reserved keywords. And remember, you cannot use these keywords as variable names. If you want to print a list of all Python keywords, you can use this block of code to print this. Having covered the keywords, let's proceed to variables. Variables are used to store data in Python. Python is dynamically typed, which means that there is no need for you to declare data type of a variable. In other languages like C and Java, there is a need to determine its data type before defining the variable. In Python, you can directly define the variables like this: x equals to 5, y equals to hello. But you need to follow certain rules while defining these variables. And the rules are as follows. Variables names must start with a letter or an underscore and can contain letters, digits, underscores, and these variable names are case sensitive. The variable names which we are defining should be descriptive and meaningful, and no spaces are allowed in between the variable names. You can use underscore to separate them, as you can see in this example, total sum. Instead of writing this, we used underscore in between them. Always remember these 2 points, that variable names should not start with a number, and we cannot use reserved keywords as variable names. Next, we will explore the final topic, identifiers. Identifiers are the names given to variables, functions, classes, etc. They must start with a letter or underscore. and can contain letters, digits, and underscore. And remember not to use keywords as identifiers. By listening to this, you may get a doubt that what is the difference between variables and identifiers. In short, variables are subsets of identifiers that specifically point to value in memory. All variables are identifiers, but not all identifiers are variables because it contains names of functions, classes, and objects also. Before closing this topic, let's see a valid identifier and an invalid identifier. In this example, variable underscore name is a valid identifier, while one variable is not a valid identifier. Let's summarize the key points we have discussed. How compiler and interpreter works. Before we dive in, let's first understand what are these. Both compiler and interpreter are software programs that transform human readable or understandable code into a format that computers can understand and execute. Coming to the topic, compiler translates the entire program into machine code before execution. Interpreter, on the other hand, translates and executes the program line by line. Let's visualize this with a workflow diagram. As we have discussed, compiler translates the entire code at once into machine code and then executes it. Moving on to the interpreter, it translates and runs the code one line at a time, which means that after execution of each line only, it goes for next instruction. Coming to the next point, execution speed is faster in compiler since entire program is already translated. In contrast, execution speed in interpreter is slower than compiler since each line is translated during runtime. Proceeding to error detection, compiler displays error after compilation, making debugging more challenging, whereas it is easier in interpreter to debug as it stops at first error. As for memory usage, compiler requires more memory as it generates object code. As interpreter does not generate object code, it uses less memory. Finally, when it comes to the languages, compilers use it with C, C++, and Java, whereas languages like Python, Ruby, and JavaScript use interpreters to translate and execute the code line by line. These points cover how compiler and interpreter works and their differences. If you feel you have learned something, answer the question and let us know in the comments. Which of the following programming language is commonly executed using interpreter? Drop a comment if you know the answer. Congratulations, you have successfully completed how compiler and interpreter works. Before we go any further in the video, if you are new to this channel, our channel is offering a free Python course to help you master programming. Your support means a lot to us. Please consider subscribing and hitting the like button. Also, make sure to share our videos in your college groups and with your friends. Let's make learning Python accessible to all. Coming to the video, how data types and operators works. In Python, the first basic thing you should be aware of is every value you store in a variable belongs to a certain data type. And these data types define what kind of data a variable holds and what kind of operations can be performed on them. As you all know, Python being a dynamically typed language, it automatically assigns data types based on the value you store in a variable. These are the various categories of Python data types. Let's explore each one in detail. First, let's understand numeric types. Numeric types represent numbers and include integer, float, and complex. Integer represents whole numbers, either positive or negative, without a decimal point. It is mainly used in indexing and counting. This is an example how we assign an integer. Moving to float. Float represent numbers with a decimal point. It is used in mathematical calculations and measurements. This is an example how we assign a float data type. Coming to complex numbers, these represent the numbers with a real part and an imaginary part. These are used in scientific calculations and signal processing. This is how we assign a complex number to a variable. Moving on to the next category, sequence. Sequence types are used to store collection of items. The main sequence types are strings, list, and tuple. A string is essentially a sequence of characters enclosed in single or double quotes. This means you can perform various sequence operations on strings such as indexing, slicing, concatenation, and iterating through each characters. This is an example on how we can store a string in a variable and how to print it. Next up is list. A list is a ordered and immutable collection of items. Here, mutable means you can change their elements and you can perform different operations like append, remove, and sort. You create a list by placing all the elements inside the square brackets and separated them by comma. As you can see in this example, we created a list named fruits which contains apple, banana, and cherry, which are separated by comma and enclosed by square brackets. It is very important to learn about list. It is because due to its flexibility and ease of use. Advancing to tuples. Tuples are ordered and immutable unlike lists, means once they are created, they cannot be modified. Tuples are defined by enclosing the elements in parentheses. As you can see in this example, coordinates, the elements are separated by commas and enclosed in parentheses. As I have already told, tuples are immutable and cannot be changed to add or remove items after the tuple is created. This immutability makes tuples useful for storing data that cannot be modified. We can access these elements in tuples using indexing similar to a list. Tuples also support concatenation and slicing. Next, we will look at Boolean. Boolean data type in Python can have one of these two values. It may be either true or false. These values are used to represent the truth value of an expression. If we consider the following example, print 5 greater than 3, it gives true, and the other 2 is equals to 4, which is false. Boolean values are often the result of these comparison operators and logical operators, that is and, or, not. These are logical operators. These are commonly used in control statement like if, while, and for to determine the flow of the program. Next, we will cover sets. A set in Python is an unordered collection of unique items. A set is defined by enclosing the elements in a curly braces. They are mutable, meaning you can add or remove elements from the set. Here, unique items means a set do not allow duplicate values. If you try to add duplicate also, it will be ignored. As it is unordered, you cannot access elements using index or a key. Sets support various mathematical operations like union, intersection, and difference. Sets are particularly useful for membership testing and eliminating duplicate values or entries. They provide a highly optimized method for checking whether a specific element is contained in the set or not. Moving forward, let's take a look at dictionaries. A dictionary in Python is a collection of key value pairs. Each key is unique and it maps to a value. For example, in this, name is the key and John is a value. Dictionaries are defined using curly braces with keys and values separated by a colon. You can access the values in a dictionary by referring to their keys. Dictionaries are mutable, so you can add, remove, update, delete either key or values. Dictionaries are incredibly efficient for storing and managing data in key value pairs and for fast lookups. Next, we will explore an interesting concept called type conversion. Type conversion is the process of converting one data type to another data type. There are two main types of conversion: implicit conversion, explicit conversion. Implicit conversion is a automatic type conversion done by Python, whereas in explicit conversion we manually convert the data type using functions. Implicit conversion is done by interpreter to prevent data loss. If we consider the following example, If we want to perform a sum in between an integer and float number, consider this int as 20 and this float as 5.6. Then Python interpreter will automatically convert the int to a float and perform the sum. As we can see, after running the program, we get the result 25.6, which is a float. Explicit conversion is also known as typecasting. This is useful when you need to ensure that the value of a specific type. Common functions used for explicit typecasting include int, float, string, and boolean. In this example, we take a look at int function. As you can see in this example, we take a num string 100 and by using int function we convert it to a integer. As we can see in the result, it is not represented in single or double quote. This means that it successfully converted to integer. Operators are symbols that are fundamental to perform various operations in Python, from basic arithmetic operations to complex logical operations. There are different types of operators in Python. Let's learn each of them in detail. First, arithmetic operators. These operators are used to perform basic mathematical operations such as addition, subtraction, multiplication, division, modulus, exponentiation, and float division. Let's take a look at this example where we have performed all these operations on these two variables a and b. If you are confused about division and float division, modulus and exponentiation, let me explain. Division divides the first operand by the second and returns the quotient. In this example, as we can see, 20 is divided by 10 and we get the quotient 2, and it will be in the format of float. Coming to float division, it also does the same, but it returns the largest integer less than or equals to the result. For example, if we consider the result is 3.5, it will give the result 4 or 3, and the result should be in integer only. Coming up modulus, it returns only remainder of the division, that is 0 in this case. Finally, exponentiation. In this, we raise the first operand to the power of this second operand. Here 10 is raised to the power 2, that is 100. If we consider 5, it will give 25. Next, let us explore comparison operator. Comparison operator, we compare two values and return a Boolean result. The operators we use in this are equal to, not equal to, greater than, less than, greater than or equals to, less than or equals to. This is an example for this comparison operator. We have performed all the operations on this. Here also the a value is 10 and b value is 20. As we can see, a is equals to b. The result of this is false, and a is not equals to b, that is true. And 10 is greater than 20, that is false. 10 is less than 20, that is true. A is greater than or equals to b, that is false, and a is less than or equals to b, that is true. Next up, we will cover logical operators. Logical operators are used to combine conditional statements. Logical operators are and, or, not, and returns true if both statements are true, or returns true if one of the statement is true. Not reverses the result. That is, if the result is true, then it makes the result false. Take a look at this execution. Here a is 10 and b is 20. 10 greater than 5 and 20 greater than 15. Here both statements are true, so the result is true. In the next, here the statement is false, as the OR statement requires only one statement to be true, so it returns true, not inverses the result. 10 is equals to 20. This is obviously false. Not reverses the result, so we get the result true. Next, we will explore bitwise operators. Bitwise operators are used to compare binary numbers. The operators which comes under bitwise operators are AND, OR, XOR, NOT, left shift and right shift. If we consider this example, a binary number that is 10 is 1010 and B 20 binary form is 10100. Here AND set each bit to 1 if both bits are 1. As you can see here, no two bits are 1, so the result would be 0. OR sets each bit to 1 if one of the two bits is 1, so the result would be 4 ones and single 0, and the binary result is 30. XOR sets each bit to 1 if only one of the two bits is 1. As you can see, there are no two ones coming together, so the result for this also 30. NOT inverts the given operator, so it changes the bits from 1010 to 0101, which is a 2's complement representation. The result will be minus 11. Bitwise left shift the bit of the operand to the left by specified number of positions. Each shift to the left doubles the number, which means if we consider there are 3 zeros and a single 1, if it is shift to left by 1, it will be doubled, means 2. If it is left shifted here to here, that will be 0100, means the value will be 4. Likewise, the value will be doubled if it goes on left shift. From here, if it shift left 1 again, the value will become 1000. That is, this bit value will be 8. It got doubled from 4 to 8. Here A is left shifted, means it will give the result 40. In the next, we used right shift bitwise operator which shift the value right by the specified number of positions, and each right shift will half the number, means if the value is 4, it is right shifted, means it will become 2. For the B, the value is 5. Next, we will cover assignment operator. Assignment operators are used to assign values to variables. The assignment operators are these. This is assign, add and assign, subtract and assign, multiply and assign. Assign operator assigns the right hand operand to the left. Add and assign adds the right hand operator to the left hand operator and assigns the result to the left hand operator. Here left hand operand is C, that is 30, which we got from the first step, and A is the right hand operator, that is value 10. When we add these in the right hand operand, C plus A, that is 30 plus 10, which gives 40. Likewise, we perform multiply and assign, which gives 80. As in the previous step, C is updated, so we get 40 into 2, 80. We also have other operators such as divide and assign, modulus and assign, exponential and assign, floor division and assign. You can search in Google and refer them. Next, we will cover identity operator. Identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. Means it should be the same object, not the similar object or identical object. Identity operators are is and is not. Is returns true if both variables point to the same object. Is not returns true if they don't point to the same object. Coming to this example, here in the execution, as you can see, x is z. As I have said, it should refer to the same object, not identical or similar object. As z is x, which has same memory location, then it returns true. In the next, as you can see, x is y. It returns false because their memory location is not same, but they are identical or similar. Next, x is not y is not returns true if they do not point to the same object as x. From the above explanation, we can tell these did not point to the same object, so we return true. Let's cover the last operator, that is the membership operator. Membership operators are used to check if a sequence is present in an object or not. Membership operators are in and not in. In returns true if the value is found in the sequence. Not in returns true if the value is not found in the sequence. Coming to the example, if we consider we have a list which contains only 1, 2 and 3 in the list. For the first statement 1 in x, 1 is present in the list, so it gives true. Coming to the next statement, 5 not in x. Not in will return true if the value is not found in the sequence. We have taken a sequence of list 1, 2, 3 which does not contain 5, so the result is true. Let's have a quick overview of some of the most important data which we have covered in this video. Conditional statements. Conditional statements allows a program to make decisions and execute different sections of code based on a specific condition. In this video, we will learn if statement, else statement, elif statement and nested if statements. First, if statement. An if statement is used to execute a block of code only if the specified condition is true. Otherwise, the code will not get executed. Coming to the if statement syntax, it starts with the if keyword followed by a condition which can be a logical expression that evaluates either true or false, and at the end of the if statement a colon is placed. In the next line you need to indent the code block. Here indentation means giving spaces. Generally it is 4 spaces or a tab space. If the indentation is incorrect, it results in an indentation error. Next, you need to write the code which is executed only if the given condition is true. Coming to this example, here age is assigned with 18 and in the if statement, the condition is if the age is greater than or equals to 18, then the code should print you are an adult. As the given condition is true, it prints you are an adult. If we consider the age is 16, then this condition fails. As we discussed in the if statement, the block of code will be executed only if the if condition is true. Here the condition fails, so it will not run the program which is under the if block. It is a limitation for this if statement as it can only evaluate a single condition at a time. If you have multiple conditions, then you cannot use this if statement. To overcome this, we can use if else statements or elif statement. Moving to if else statement, the if else statement allows you to execute one block of code if the condition is true and another is false. Coming to if else statement syntax, the first if block is same as the above we discussed. As for the else part, which is an alternative action, if this if condition fails, you use else keyword followed by colon. Then you need to indent the code to avoid indentation error. Coming to this example, we defined age as 16 and the if condition is age is greater than or equals to 18. As here the age is 16, this if condition fails, so whatever the block of code which is present under the else block will be executed. As for this example, you are a minor will be printed. Before going to elif statement, you need to understand that the control flow in if statements will be sequential. Means first the if block will be executed, then only the else part will execute. This is same for ELIF statement also. It won't directly enter the else block without executing this if statement. Here sequentially means in order. Next up, ELIF statement. The ELIF statement allows you to check multiple conditions in a sequence, and this ELIF is the short form for else if. It is used after an initial if statement and before an optional else statement. The syntax for this starts with if followed by a condition and colon. After this, an indented block of code to execute if the condition is true. If the initial condition is false, then the ELIF keyword allows for another condition to be checked. ELIF followed by condition colon and again indented block of code to execute if this new condition is true. This process can continue with as many ELIF statements as possible. There is no limitation that you can use only this many ELIF statements. You can use n number of ELIF statements in the if block. Finally, an optional else keyword followed by colon can be used to handle any condition that were not meant to be true in the above, providing a default action. This is how ELIF statement syntax works. Coming to this example, here marks are defined 75. Entering the if statement, here the condition is marks is greater than or equals to 90. As this condition fails, we enter into ELIF statement. Here marks is greater than or equal to 70. As this condition is satisfied, it will print grade B as the output. And one more important thing you need to remember when dealing with if else and ELIF statement is once a condition is met, the corresponding block of code only is executed. In this case, grade B is printed and no further conditions are checked. Means this else block will not get executed. I think this should clarify the working of if else and ELIF statements. Now let's delve into nested ifs. Nested if statements are if statements that are placed within the body of another if statement. This allows you to create complex decision making structures where multiple conditions can be evaluated and different actions can be taken based on their outcomes. Coming to the syntax, it is same as we have said in the definition. An if statement is placed inside another if statement. You can place n number of if statements inside another if statement, but with the increase of each nested if statement, it will impact its readability and performance. Coming to this example, here age is defined 20. If age is greater than or equals to 20, here the condition is true, so the control flow will enter in this if block. Again, this condition is checked whether age is less than 21. Here the condition is also true, so the code block which is present in the if statement will be executed. That is, you are an adult but not old enough to drink. In other cases, if the outer if loop condition is false, then the control flow will not enter this if block and the output will be empty on the output screen. And if you had provided any else statement for this if block, then that block of code which is under the else block, that will be executed. By this we end conditional statement. Next we are going to cover for loop. A for loop is a control flow statement used in programming to execute a block of code repeatedly for a specified number of times. This simplifies the repetitive tasks and makes code more efficient. Moving to its syntax, it starts with a for keyword followed by a temporary variable that takes on the value of each element in the iterable during each iteration. This variable can be named anything you like. Next, in keyword that specifies the sequence you want to iterate over. Finally, the sequence, which is the collection of items you are looping through, such as list, tuple, string, or range. At the end, colon. In the next line, the code should be indented the trunks for each item in the sequence. Otherwise, it raises an indentation error. Turning to this example, where we need to print from 1 to 3, the for loop begin with the for keyword followed by the I variable that will be used to represent each element during the iteration. Next, in keyword along with this range function. The range function generates a sequence of numbers which we can use during the loop. This is the starting value and the ending value which is excluded from the range. Means if you take from range of 1 to 20, this will print from 1 to 19 only. The number which we give here will be excluded, means n minus 1. As for this example also, as we need to print from 1 to 3, we give the ending range to be 4 so that it can print from 1 to 3. In the next line, we indent this code. The execution for this code will be as follows. First, the loop starts with the first number in the range, in this case 1, print this number and goes for another iteration. On each iteration, variable is set to the next number in the range, that is 2 for the next loop. It enters the for loop and it prints number 2. This loop continues until it goes through all numbers in the specified range. Then it will stop iterating. In place of this range, you can directly use list, tuple and also string. Now in place of this list, you can place for number in num. After executing this, the output will be this. By mastering this for loop, you will be able to tackle various DSA problems and excel in programming interviews. If you want to learn DSA for free, you can go through this channel playlist where you can find videos on various topics on data structure and algorithms. Next, we will learn about while loop. While loops are control flow statements that executes a block of code repeatedly as long as the specified condition remains true. They provide flexibility in programming, allowing you to create dynamic and iteratable process. The syntax for this while loop starts with while keyword followed by a condition and colon. In the next line, the code should be indented to avoid indentation error. Coming to this example, we defined count as 3. Entering the while loop, the condition is until and unless count is greater than 0, it should print the count value. Enter the while loop and the condition is met as the count is greater than 0. So we print while loop and the count value is 3. In the next line, we decremented the count by 1. So the count value will be decreased from 3 to 2 and it again goes back to while. Now the condition 2 is greater than 0. So it again enters the loop and prints while loop colon count. In the next, the count is 2. This loop will continue to execute until this condition is true. If the condition becomes false, that is, if the count value is 1 and it printed the while loop 1, in the next line the count will be decremented to 0 and the control flow will be returned to while. Here the condition will become false because 0 is greater than 0. The condition is false, so this while loop will be terminated. This is how execution goes in while loops. In while loop, we should be cautious of infinity loops. If the condition never fails, then this loop will continue to iterate infinitely. To break this, we use control statements. Next up, we will learn about control statements. Python provides loop control statements to alter the flow of loops. They are break, continue. Break statement stops the loop immediately and exits the loop permanently. As we can see in this example, if I is equals to 3, then this break statement will execute. After printing 0, 1 and 2, as this condition is met, this break will stops the loop immediately and exit the loop. So we cannot see the break example 3 and 4 to be printed in the console. Moving to continue, the continue statement skips the current loop iteration and moves to the next one. From this example, we can see If I is equals to 3, then this continue condition will be met and it will skip that loop and it will move to the next loop. As we can see in the execution, it has print 0, 1, 2 and skipped 3 because of this continue statement. Then we continue the loop and print the 4. The difference between this break and continue is it will break the loop immediately and exit the loop. From this example, we can see it only printed up to 2. It break the flow where 3 and 4 should be printed. Coming to this continue loop, it skipped the number 3 as the condition is met. This is the difference between continue and break. Before we go any further in the video, if you are new to this channel, our channel is offering a free Python course to help you master programming. Your support means a lot to us. Please consider subscribing and hitting the like button. Also, make sure to share our videos in your college groups and with your friends. Let's make learning Python accessible to all. Coming to the video, functions. First, let us know what is a function. A function is a block of reusable code that performs a specific task, which means that once you have written a function, you can use it multiple times without rewriting the code. Next, functions help in organizing code. It means functions help in organizing the code by breaking down complex problems into smaller, manageable pieces, allowing code reusability and reducing redundancy, making code more readable with meaningful names, and simplifying overall structure and hiding complexity. Coming to the syntax of functions, function definitions start with def keyword, followed it with the function name and parenthesis. Inside the parenthesis, you can define parameters which are optional. Parameters are nothing but the variables that the function accepts as input, and end the function header with a colon. Under the function definition, indent the code block with usually 4 spaces. This makes Python statements valid. You can also use return statements to send an result back to the caller. If no return statement is used, the function returns none by default. Now let's explore why functions are essential in Python programming. We will delve into this concept with a practical example. Consider this example where you need to calculate marks and percentage of students without using functions. First, you need to initialize student name, marks, their total sum and percentage. These steps, you need to type these over and over again for each and individual students. Let's write the same code using functions. In this, we have initialized a function called calculate and print results, and we are providing students as its parameters. In this, we use it for loop and it will iterate for each and every student to calculate their marks, percentage and to print. And outside this function, we are providing parameters of individual students and we are calling the function here. Now let's compare both of them. By seeing this, you may tell there is just a few lines of difference. For example, consider instead of 3, you need to print and calculate 5000 students' details. By writing the code without using functions, the code becomes lengthy and complex. And if you want to add any new parameters in the middle also, it will take a lot of time to insert the code. And if there is any error while calculating the student marks in the formula, modifying the code for changes will become very difficult and it may raise a lot of errors also. If we come to lines of code, for each and every student, it will take up to 5 lines. If we consider this print statement also. For printing 5000 student details, it will take 25,000 lines. Whereas writing the same code using functions only, number of parameters will be increased to 5000. The remaining code will be the same, which means the number of lines will be 5006 only. And if there is any error in percentage formula also, we can just change the formula in the function and we can again call this function. From these examples, as you can see, the lines of difference is also very huge. Without using function, you need to write 25,000 lines, and with using functions, you need to just write 5006 lines only. And this tells the importance of using functions in our code. Coming to the advantages of functions, From the above example, we can tell function allows you to write a block of code once and you can use it multiple times, reducing redundancy, which means the number of lines you need to write will be reduced significantly. Functions offer several benefits for Python programmers. In those, modularity is very important. In this, complex problems can be broken down into smaller and manageable functions. Next, maintainability. As you have seen in the example, if there is any logic error in the code, changing the logic will only affect the function itself, minimizing unintended consequences. In other words, you can tell it is easier to update and manage the code. Finally, functions makes the code more readable and organized. If we compare the codes with and without using function, the code which is written using the functions is more readable and organized than compared to the code which we write without using functions. These are few advantages of using functions in the code. If you think you have gained some knowledge by watching the video, comment the answer for this question as it will help my channel to grow. What is a function in Python? Comment the answer in the comment section. We are going to explore difference between iteration versus recursion and local scope versus global scope. First, we are going to learn about the difference between iteration and recursion. We consider a program is in iteration if there is a loop present in it. Example, for loop and while loop. And iteration is a process of repeating a set of instructions multiple times. Moving to recursion, a program is said to be in recursion when a function calls itself either directly or indirectly. Iteration is faster than recursion. Recursion tend to be slower because of the overhead of the multiple function calls and managing the call stack. Iteration solutions generally require more lines of code since the loops must be explicitly defined and controlled. Recursive solutions are generally shorter since the function handles the repetition by calling itself. Next, the most important thing you need to remember while dealing with iteration and recursion is how to terminate them. In iteration, termination is based on loop condition. If the condition is not properly defined, it may lead to an infinite loop. To stop that, you need to use control statements, which I have already told in episode 3. You can go through the playlist to learn about them. In recursion, termination requires careful base case definition. If you don't know what is base case in recursion, let me explain. Recursion is always made up of two portions. They are base case and recursive case. The base case is the condition to stop the recursion, whereas the recursive case is the part where the function calls itself. If we do not have a proper base case to stop the recursion, then this function will call itself infinitely, leading to recursion error. This is an example for iteration where we use for loop which runs from 1 to 6, printing each number. This is an example for recursion where this function calls itself decrementing from 5 to 1. In this, the function calls itself decreasing n with each call until it reaches 0 and then terminates the function. Next up, local scope versus global scope. Local scope variables are defined within a function or a block. As you can see in this example, x equals to 10 is a local scope variable which is defined inside my function. In global scope, variables are declared outside all functions. As you can see in this example, x equals to 10 is defined outside of this function. A variable in the local scope is only accessible within a function where it is declared. If you run this function, it will return 10 in the console. But if you include this print x, it will raise an error that x is not defined. It is because, as I have already said, it is only accessible within this function. Outside the function, we cannot access this local variable. Global scope variables are accessed anywhere within the program, including inside functions and outside functions, which means if you run this code, you will get two tens in the console. Coming to modification in local scope, if you have given same name for global variable and local variable, the local variable will shadow the global variable inside the function, but it will not modify the global variable outside the function. Means if you have declared the global variable x equals to 20 and inside the function the local variable as 10, if you run this code, this will print first 10, next 20. This is because functions consider local variable over global variable. This happens only if you provide the same name. Global scope variables can be modified globally using global keyword inside the function. If you need to change any global value inside a function for local variables, as you have seen in this example, you don't need any keyword to change them. You can directly declare them. This will change the global value inside that function only. Whereas in global scope, there is a need for using global keyword to modify global value inside functions. Now let's continue the video with Lambda function. Lambda function, often referred to as small anonymous functions that can have any number of arguments but only one expression. It is often used for quick short tasks where you don't need to define a full function. There are a concise way to define functions in Python. Lambda syntax is as follows. You can create a lambda function using the lambda word followed by arguments and an expression. These arguments can be a comma separated list or a single value. Coming to this example, square equals to lambda. In place of arguments, we are providing x, and in the place of expression, we are providing x asterisk x. In the next line, we are printing lambda example square, that is square of 5, where 5 is the argument. When this lambda function is called, the arguments are passed into the expression which is evaluated and returned. As for this example, 5 is multiplied by 5, so the result will be 25. In this lambda function, there is no need for using return statement as the result of this expression is automatically returned. While using normal functions, there is a need for using these return statements. Lambda functions are designed for short and one-line expressions. For complex expressions, you need to use normal functions. Lambda functions are also used as temporary functions within other functions or expressions. Next, we are going to learn about modules. A module is a file containing Python code related to functions, variables, or classes that you can use in other programs. Python comes with a standard rich library that provides a vast collection of modules for various tasks. Examples of these modules are math, OS, random, etc. Beyond the standard libraries, there are a thriving ecosystem of third-party modules available through different platforms, offering solutions for specific domains like machine learning, web development, scientific computing, and more. You can create a module by saving a Python file with .py extension. This file name will be the module name. In that module, you can write your functions, classes, and variables. In another Python file, you can use import statement to import that module. By this way, you can import and create your own module. The syntax for importing module is import keyword followed by module name. In this example, we are importing math library, and using this we are finding the square root of 16. The output will be 4, which is a float. In the next example, if you only need certain elements from the module, you can import them directly by using from keyword followed by the module name, import followed by function name or class name. In this example, we are specifically importing pi from math module. In the next line, we are printing the pi value, that is 3.14. The important thing you need to consider while creating the module is you should give meaningful module name that reflect their purpose. Next, we will discuss about packages. A package is a collection of multiple modules grouped together to organize the code better. A package is basically a folder containing several modules and a special file called init.py file. You can create a package by following these steps. First, you need to create a folder called my package, or you can use other names also. Inside the package, create an empty file named init.py. This file indicates that the my package folder is a Python package. Place your modules inside the package. Here module1.py and module.py is the modules. To use these packages, you can create a separate Python file in the same directory as the my package folder. Now let's take a look at this my package example. You can see in this image we have created init.py file, module 1 and module 2 and another file to use these packages. In the module 1, we have created the function greets which will greet hello and the name which we have imported from the arguments and welcome to my channel. In the module 2, we are performing addition in one function and multiplication in the other function. In the main.py file, we are importing the previous packages here and we are providing the arguments and calling the functions which we have assigned in the modules. Finally, we are printing them. In the init.py file, you can leave it empty or you can include package level imports in this. This is the result for executing the package. Let's quickly summarize what we have learned. Before we go any further in the video, if you are new to this channel, our channel is offering a free Python course to help you master programming. Your support means a lot to us. Please consider subscribing and hitting the like button. Also, make sure to share our videos in your college groups and with your friends. Let's make learning Python accessible to all. Coming to the video, we are going to learn about Python most commonly used operations on data structures like strings, lists, and dictionaries. These structures are the building blocks for almost everything we do in Python. Python offers a variety of data types. If you want to know them in detail, you can watch episode 2 of Python programming series. Coming to the video, there are three data types which stand out when we need to store and manipulate data efficiently. They are strings, lists, and dictionaries. First, let us know about strings. A string in Python is an immutable sequence of characters. Here, immutable means once they are created, we cannot change them. But we can create new strings with modifications. Strings lets us to work with text for storing and modifying the messages. Moving to operations on strings, concatenation, slicing, and methods are the most commonly used operations. Concatenation is the act of joining two or more strings together. Slicing is accessing part of strings using indexing ranges. It is just like cutting a slice of cake where you specify the start and end positions and Python starts extracting the part of the string you mentioned. Next, methods. Python strings comes with many built-in methods. These are the most commonly used. Let's learn about them in detail. The following examples. Here we are assigning hello world string to the text by using assignment operator. Before continuing with this example, I want to tell you this that most built-in functions in Python have meaningful names. From their names itself, we can tell what is their function they are going to perform. In this example, we are using upper method to convert all characters in the text string to uppercase and using print to print them. If we execute this, we will get the result hello world in capital letters like this. In Python, all built-in string methods are written in lowercase only. If you see here also, all of them are in lowercase. Additionally, it is important to use this dot notation to call methods like this. This dot notation is important in Python because it tells the Python that you are invoking a method on a specific string object. In the next example, we are performing slicing operation. To do slicing operations, You need to always use these square brackets after the string where you want to perform the slicing operation. As I have already said, slicing is like cutting a piece of cake where you specify the start and end positions. In this example, we are extracting characters from 0 to 4 because the ending index is omitted or excluded, so it extracts from 0 to 4. Before continuing, let us know about indexing. Indexing is a method used in Python programming to access individual elements within a sequence, and it always starts from 0 if you are accessing the string from left hand side. Python also supports negative indexing where -1 represents the last element and -2 represent the second last element, in this case D. In this example, we are extracting characters from index 0 to 4. That means H is index 0, E is index 1, L is index 2, another L is index 3, and finally O is at index 4. If we print this, we get the output hello. As we have already discussed how upper method converts all the characters to uppercase, lower method converts all the characters to lowercase. Strip method is used to remove leading and trailing white spaces. As you can see in this example, text has two leading and two trailing white spaces. By using this strip function, we did not get any leading and trailing white spaces in the console. This is how strip method works. Replace method. It is used to replace old instances with the new in the string. In this example, we are replacing Python with Java. In the output screen, you can see in place of Python, we are getting Java programming. You can also see the leading and trailing white spaces here. As we have not used this strip method. Coming to advanced operations on strings, we use split method to split a string by a specific delimiter and it returns a list. In between the brackets, you can mention any specific delimiter. If you did not provide any specific delimiter, it will take the white space as a delimiter. Generally, we use comma as a delimiter. As you can see in this example, sentence is assigned as Python is fun. In the next line, words is assigned with sentence dot split method, which converts the string in the sentence into a list of substrings. By executing this code, we get the output like this. Here, as we have given no delimiter, it will take white spaces as default. So wherever white space is present in the string, it will convert them into substrings inside a list. As you can see here, spaces is present, it will convert each of them into substring. Python is fun. And if you are still confused about delimiter is nothing but a character at which to split the string. Wherever the delimiter is present, it will split this string. If you did not provide any delimiter, it will take default as white spaces. Next, join. Join is most commonly used on list, as we have already converted this sentence into a list and assigned to the word. So we are performing this join method on word. And don't forget to use this dot notation, as it is important to call these methods. This join method is used to create a single string by concatenating elements separated by a specific separator or delimiter. To perform this join operation, in the codes you need to mention this separator, which should be present in between the strings. Here we are providing white space as a separator. After running this code, we get Python is fun, and in between them the white space is present. Instead of white space, if you provide dash, then this dash is placed in between the substrings. Join method can also be used with any iterable like tuples, set, and other sequence types. By this we have covered some of the most commonly used string functions in Python. but there are many built-in string methods available. To explore them more in detail, I recommend you to check out online resources like the official Python documentation that can help deepen your understanding. Next, let's explore list. Lists in Python are mutable, meaning elements can be changed or modified in the list. A list allows us to store multiple items in a single variable. Some basic operations on list include accessing elements, adding, removing, and sorting elements. Accessing elements in list is same as we accessed elements in the string. By using indexing, we can access specific items. Adding elements in the list can be done by using these three methods. Append method adds a single element to the end of the list. Insert method allows us to place an item exactly where we want in the list. And finally, extend method adds multiple elements to the list. Many people confuse about extend and append. It should be clear that append is only used to add single element at the end of the list, whereas extend function is used to add multiple elements to the end of the list. I hope this clears the difference between them. For removing elements in the list, we use remove, pop and clear methods. Remove method uses the value to delete the object from the list. Pop uses index number to delete the object from the list. And clear method removes all elements from the list at once. For sorting elements in the list, we use sort and sorted method. First, let us know about sorted method. This sorted method does not modify and sort the original list, but it creates a new sorted list. Whereas this sort method modifies the original list and do not create a new list. This is the difference between sort and sorted. Moving to the examples, here item is assigned with a list which contains apple, banana and cherry. We are appending date to the items. The element which you are appending into the list should be placed in between these brackets only. By printing this list, we get date at the end of the list. This is the syntax for the append, where you need to place the item which you are going to add into the list in between these brackets, and it will be added to the end of the list only. As you can see in the example, we are appending C into the list and the output will be ABC. To insert elements at a specified index, we use insert function, and this is its syntax. Index followed by item. In the example, at index 1 we are inserting O. The indexing is also starts from 0 only. So the insert method will place this O at index 1, and the element which is already at index 1 will be shifted to index 2. By printing this, you can see O is placed at index 1 and B is shifted to index 2 and so on. Next, remove method. It removes the specific element which is given in the instance. Here we are providing O. After printing the result, it would be ABC only and O will be removed from the list. Next up, advanced operations on list. List comprehensions in Python provide a easy way to create list and involves a for loop that processes each iteration in a sequence. These list comprehensions are useful in Python for creating new list by applying an expression to each item in an existing iterable, like a list, tuple or range. Coming to the example here, for creating squares of each element in the list, instead of using traditional for loop, we use this list comprehension to make it easy to read and create a list. Coming to this example, numbers is assigned with a list of 1, 2, 3 and 4, where we are generating squares for each number in the list. To do that, we are using list comprehension. By executing this, it generates a list of squares, and we have already discussed about this sorted list, which creates a new sorted list instead of sorting the old and original list. And this copy method is used to create a shallow copy of the list. By this, we have covered some of the most commonly used list operations. If you want to gain more in-depth knowledge, you can go through official Python documentation or visit websites like Geeks for Geeks. Next, dictionaries. Dictionaries are unordered, mutable, and contain key value pairs. Dictionaries are used to store data when they are in the format of key and value pairs. You can also think this key value pairs as question and answer pairs. Some basic operations we can perform on dictionaries are adding or updating entries, accessing values, and deleting entries. You can add or update elements by assigning a value to a key. In the examples, we are adding grade to student dictionary by assigning value A to grade. By doing this, we get grade at the end of the dictionary. You can access values by referencing to their key, and you can use get method for avoiding errors if the key is not found. To remove elements, you can use this pop method or del statements or pop item method. For adding and updating elements, this is the syntax where you need to specify dictionary key and the value you are assigning. To remove values, you can use this pop method, which removes the key and returns the value, or you can use clear method to remove all items from the dictionary. In this example, we are updating age, which is 25, with 26. In the next line, we are removing name from the dictionary by using this pop method, and it is necessary to use this dot notation. As I have already said, it is used to access these methods. Finally, we are printing them and the output will be like this. As we have removed name, so it won't be present in the output screen. And the age is also updated from 25 to 26. Lastly, we have advanced dictionary operations. Just like list comprehensions, dictionary also support comprehensions for easy creation of dictionaries. Dictionary comprehensions provides a more concise and readable method for creating dictionaries compared to traditional for loops. It removes the necessity for loop initialization, iteration, and manual appending to the dictionary. Instead of these traditional process, in a single line, we can perform all the changes we want. The syntax for dictionary comprehensions is key colon value and followed by for loop. It iterates over each item in the dictionary where each key value pair is determined by the expression which we given inside these braces. In this example, we are squaring each value in the range from 1 to 6 and we are printing in the next line. The output will be like this. We can merge two dictionaries by using this update method. In the example, we have dictionary 1 and dictionary 2. By using this update method, we are merging them and we are printing in the next line. As we can see, dictionary 1 has only A and B and dictionary 2 has C and D. By using this dictionary method, we have all these placed in the dictionary 1 only. Error handling in Python, which will guide you to understand and manage exceptions to make your code more reliable and robust. Let's start with the basics by understanding what is an error. In Python, errors are also known as exceptions, which can interrupt or stop the execution of a program. By using error handling, we can improve code robustness, meaning we give the code ability to handle errors and makes debugging easier and code reliable. To overcome these errors, Python provides a systemic way to handle these errors by using try and except blocks. With that understanding, Let's look at various types of errors you may commonly encounter in Python and how can it impact our program. Python has several error types. In those, syntax error, type error, value error, and zero division error are the most common error types we encounter during an execution. Syntax error occurs when Python syntax is incorrect. In the following example, as you can see, there is a missing colon at the end of the syntax. As the syntax is wrong for this if block, if you try to execute this, then syntax error will arise. Like this, whenever a code violates the rule of Python language syntax, syntax error will arise. Some common causes of syntax error include missing or misspelled reserved keywords, spaces, quotes placed improperly, indentations, and incorrect usage of blocks, invalid declarations, etc. Next, type error. A type error happens when we perform operations on incorrect data types. For example, we are performing addition in between an integer and string, which are incompatible data types to perform this addition. Like this, errors in Python comes in many forms, each with its having many examples. While I will cover the most common types and provide a clear example for each error in this video, there is a whole world of additional scenarios and examples out there. If you are curious to learn more examples on each error, I recommend you to browse through the net, which can offer a lot of information. Coming to the video, next up, value error. A value error occurs when a function receives an argument of the right type but an inappropriate value. From this definition, you may be little confused, but if you carefully understand the example which I am going to tell now, you can easily learn this topic. In the example, the int function is called with the argument abc. This int function is a built-in Python function that converts a given value to an integer. Here, the argument which we provided is of integer type. The int function can only convert the string to integers only if the string represents a valid integer. Means if the strings would be like 1, 2, 3 in double quotes or any number in double quotes is considered as string. Those strings can be converted into integers, but these ABC or any form of alphabets in double quotes cannot be converted into integers. So ABC cannot be converted into an integer. Python raises a value error. Moving to zero division error. Zero division error. From the name itself we can tell it is raised when we divide it by 0. As you can see in this example also, we are dividing 7 by 0. So when we run this program, we get zero division error. Now that we have seen some common error types, let's explore a few more specific ones, especially those related to mathematical and index based operations. Index error, which is raised when we try to access an invalid index which is not present in a list or tuple. For example, if you consider this list, it has index from 0 to 2. In the next line, we are trying to access the index of 5 which is not at all present in the list. So in these cases, as we are trying to access an invalid index which is not present in the list, index error is raised. Moving to arithmetic errors. It can occur when the arithmetic calculations fail, and it is the base class for those built-in exceptions that are raised for various arithmetic errors like overflow error, zero division error, and floating point error. Coming to the example, if we try to find the square root of -1, Python program will raise an error to a negative number which is not defined within the domain of real number. Square root can be done only when the number fall into the domain of real numbers only. Instead, this -1 belongs to the domain of complex numbers. So Python raises arithmetic error. It may be little bit confusing to understand. But in simple words, you can tell arithmetic error exceptions arise when a mathematical operation fails due to invalid input, which is -1 here, or operations. In those cases, arithmetic error exceptions arise. An overflow error is raised when a calculation exceeds the maximum allowable value or when the input size exceeds the initialized size of the variable. In these cases, this error will occur. Coming to this example explanation, the exponential function is used to calculate the exponential of the given argument. In this case, that is, when you try to find the exponential for this, the result will be large and exceeds the maximum value that a float can represent in Python. Since the result for this is very large, Python raises an overflow error. Next up, floating point error. Floating point error occurs when the calculation of floating point value fails due to limitations of binary representation and precision. Generally, floating point numbers are stored in a binary format. Some decimal numbers like 0.1 and 0.2 cannot be represented exactly in binary. Instead, they are stored as approximations. Coming to this example, when you try to perform addition in between 0.1 and 0.2, the result will not be exactly 0.3 due to these precision errors. The actual result of 0.1 plus 0.2 in binary is slightly more than 0.3. So this comparison results false. In addition to arithmetic and index errors, Python also has other error types that often arise during importing, file handling, and working with dictionaries. Let's go over those next. Import error occurs when Python cannot find the module you are trying to import. This usually happens if the module is not installed or the given file name is wrong or mismatched. In the following example, we are trying to import a module named non-existent module. Python looks for this module in its list of installed packages. Since non-existent module does not exist, Python cannot find it. So it raises an import error. Key error. Key error occurs when you try to access a dictionary key that does not exist or mismatched in the dictionary. In this example, simple dict is a dictionary which has only one key, that is name. In the next line, we are attempting to access the key age which does not exist in this dictionary, leading to a rise in key error. Next, name error. Name error occurs when you try to use a variable or function that has not been defined or not found. Here, variable is not defined before it is used, leading to name error. Lastly, file not found error. A file not found error occurs when you try to open a file that does not exist. In the example, I am attempting to read a file named non-existent file which does not exist, so it raises a file not found error. By understanding and handling these common Python exceptions, you can make your programs more reliable and user-friendly. Now that we have covered the types of errors, let's discuss how we can handle them in Python using basic try and except blocks. Using the try and except block allows you to handle exceptions gracefully, providing alternative actions instead of crashing your program, so that you can ensure your programs run smoothly even when an error arises. The basic syntax of try and except is try followed by colon. In the next line, indent the code. After that, write the code that might raise an exception. Next, except followed by exception type and colon. In the next line, indent the code and write the code to handle this exception. You should always know that Try block contains the code that might raise an exception. In this case, dividing 10 by 0 raises a 0 division error, and the except block catches the 0 division error and execute the code to handle it by printing an error message that is cannot divide by 0. If you run this program also, you will get the output cannot divide by 0. Instead of crashing the program, the try except block caught the error and handled it. While a single except block works well for one type of error, in many cases we need to handle multiple specific errors. Python allows us to do this with multiple except blocks. Here is how. You can handle different types of exceptions using multiple except blocks. This example handles two types of exceptions: value error, which occurs when a function receives an argument of the correct type but an inappropriate value, and the next exception is type error, which occurs when we perform operations on incompatible data types. When we execute this code, we get output as value error occurred, as we have provided string to be converted into int, which is not possible, so value error occurred. Instead of Python, in string, if we had any numeric values, we can convert that number to int. As we cannot convert any alphabet into numeric, so we get this value error. In some cases, we may want to take action only if there is no error in our try block. This is where the else clause becomes useful. Let's see how it works. The else clause is executed if no exceptions are raised in the try block. Coming to this example, in the try block we are performing division and assigning it to the result. As this division will not raise any exception, this else clause get executed and displays the result, that is 5. Instead of 2, if it has 0, this except block will get executed and will print the result cannot divide by 0. In the try block, as the exception is occurred, this else block will not get executed. I hope this clears your doubt. When will this else clause will get executed and when will it does not get executed. Finally, there are some situations where we need certain actions to happen no matter what, whether an error occurs or not. For that we use the finally block. The finally block is executed after the try and except block. Regardless of whether an exception was raised or not, this final block will get executed. If we execute this code, we get the result value error occurred, and also this finally block will get executed printing this is finally block, it always runs. The finally block can be used with or without this except block. If no exceptions are expected to be caught, you can use try and finally without except. Before we go any further in the video, if you are new to this channel, our channel is offering a free Python course to help you master programming. Your support means a lot to us. Please consider subscribing and hitting the like button. Also, make sure to share our videos in your college groups and with your friends. Let's make learning Python accessible to all. Coming to the video, object-oriented programming in Python. I will guide you through its core concepts like class, object, inheritance, encapsulation, polymorphism, abstraction, method overloading, and method overriding with examples. Object-oriented programming, as the name suggests, is a programming approach that organizes the code using objects, which are instances of the class. We use object-oriented programming because it offers a number of benefits. The main benefits include maintaining clean and organized code, allowing reusability of code to reduce redundancy, and break down complex program into smaller and manageable parts called class and objects. This makes the code easier to understand and debug the code. Python support object-oriented programming concepts such as inheritance, polymorphism, encapsulation, and abstraction. Let's move ahead to explore these in detail, starting from class and objects. The classes and objects are the very core of object-oriented programming, where a class is defined as a blueprint for creating an object, and an object is defined as an instance of a class. To understand it simply, think a class as a blueprint like a plan for building a house, where the object is the house itself built using the plan. Coming to this example, this line defines a new class named person, and the syntax is as follows: class keyword followed by class name and colon. In the next line, init method is used, which is a special method in Python known as constructor. This init method task is to initialize object attributes when they are created. When a new object is created, the init method is automatically called to set up the object. Self allows access to the attributes and methods of a class in Python, and it is a reference to the current instance of the class or object. Inside the init method, we are having the attributes of this class. In this case, these two are the attributes. In this line, we are assigning the value of the name parameter to the instance attribute name. This goes same for age also. This code defines a person class. Person1 is the instance of the class or object. As I had already said, a class is a blueprint. We are creating this person1 object from the blueprint, that is from the person class. This person1 object is actual object which is created from this class blueprint. I hope this clear why we call class as a blueprint for creating object and why an object is an instance of the class. As you can see in the example, we are creating this person1 object using this person class with the set of attributes name and age. This line prints the name and age attribute of the person1 object. It will output Alice 25. With this, we have completed classes and objects. Moving on, let's talk about encapsulation. Encapsulation is the concept of bundling the data and the methods that operate on that data into a single unit. This is the official definition for encapsulation. In simple words, you can tell encapsulation is about keeping the details of the object hidden with controlled access. It involves restricting direct access to some of the object components, which is also known as data hiding. Let's talk about access specifiers, a key component of the encapsulation in Python. These specifiers controls the visibility and accessibility of the attributes and methods within a class, ensuring proper use and data protection. Python offers three levels of access: public, private, and protected. First, public members. Public members are fully accessible from anywhere in the program, inside or outside of the class. This makes them the most open type of access specifier. Private members provide the highest level of restrictions. Members with double underscore are private. They are only accessible within the class they are defined in. Private members are useful for safeguarding sensitive data and ensuring that it cannot be modified or accessed directly from the outside class. For this, Python uses name mangling. Finally, protected members. Members with single underscore are protected, whereas double underscore are private. And don't get confused between init method and private members. Init method is not a private member. Coming to protected members, they are intended for the use within the class and its subclasses. By strategically using access specifiers, we can implement robust encapsulation, safeguarding the integrity and security of our code. Now let's move forward Let's take a look at this encapsulation example where you created a class named bank account with a private balance attribute and a method to retrieve the balance. This double underscore before balance indicates that it is a private attribute, which means it cannot be accessed directly outside from the class. This method getBalance is a getter method that returns the value of the private attribute balance. This line creates a new instance of the bank account class and assigns it to the variable account. As I have already said, whenever you create a object, the init method is automatically called and the self dot underscore underscore balance is set to 1000 for this account object. In the last line, we call the getBalance method on the account object to retrieve the balance and print it. It will output 1000. With this, we have completed encapsulation. Let's move forward and explore inheritance. Inheritance allows new class to inherit the attributes and methods of the existing class. This promotes code reuse and reduces the effort needed to create a new class. In simple words, you can tell inheritance is like a child inheriting the qualities from their parent. Coming to this example, we are creating a class named animal. Inside the class, there is a method called speak. When called, it will print animal speak. In the next line, we are creating a class named dog that inherits from the animal class. This means that dog will have all the methods and attributes of animal class. But you can also add or override methods and attributes specific to the dog. Inside the dog class, there is a method called speak that overrides the speak method from animal class. When this method is called, it will print dog barks, not animal speaks. This line creates an instance of dog class and assigns it to the variable dog. Finally, this line calls the speak method in the dog instance, which prints the output dog barks. Next up, polymorphism. Polymorphism simply means having many forms. It allows methods to have the same name but behave differently based on the class they belong to. If you see this picture, here a man is playing three different roles based on the situation they are in, which means the same function is being used for different types. Coming to this example, both bird and ostrich have a fly method. This common method name allows polymorphism. The ostrich class is inherited from the bird class but overrides the fly method with its own implementation. This means that when both bird and ostrich have a common fly method, they behave differently. You can call the fly method on both bird and ostrich despite the same method name. Each class implementation of fly is different, demonstrating polymorphism. When this bird.fly is called, the fly method in the bird class is executed, printing birds can fly. When this ostrich.fly is called, the fly method in the ostrich class is executed, printing ostriches cannot fly. With this example, I explained how polymorphism allows a method to be called on different objects with each object representing in its own unique way. I hope this clarifies how polymorphism works. Next, abstraction. Abstraction is the process of hiding irrelevant details from the user and showing only the details that are relevant. Think of it like you are driving a car. When you are driving a car, you interact with the steering wheel, pedals, and dashboard. You need to know how to control these while driving the car, but you don't need to know the complex working of the car engine, transmission, and other internal components which are hidden from you. You can focus on driving without worrying about the detailed mechanics. In object-oriented programming, abstract classes are used to achieve abstraction. An abstract class is a class that cannot be instantiated directly. This means you cannot create an object from an abstract class. Instead, it serves as a blueprint for other classes. In Python, we use ABC module to create abstract classes, where this ABC stands for abstract base classes. Let's see how we can define an abstract class using this ABC module. First, you need to import the ABC class and abstract method decorator from the ABC module. And if you don't know about decorator, a decorator is a function that takes another function as an argument and alters its behavior. Decorators are applied using @ followed by decorator name above the function definition. Going to the example, next we define an abstract class with an abstract method. Here vehicle is the abstract class and start engine is an abstract method. This abstract method decorator is used to indicate that this method must be implemented by any subclasses. This is how we define a abstract class and method. Now let's create a subclass that inherits from the abstract class and implements the abstract method. In this example, car is a concrete class. The difference between concrete class and abstract class is we can directly instantiate to create objects. But in abstract class, we cannot directly instantiate to creation of objects. This car inherits from vehicle and provides an implementation for this start engine method. When we create an instance of the car and call the start engine, it prints engine started. To sum up, abstraction helps in managing complexity by hiding irrelevant details and exposing only the necessary parts. Abstract classes in Python using the ABC module and the abstract method decorator provide a powerful way to implement this concept. Moving on, method overriding. Method overriding is a feature in object-oriented programming referred as defining a method in a subclass with the same name as a method in its superclass. There are few key points that you should keep in mind while dealing with method overriding. These are: method overriding requires inheritance. The subclass inherits the method from the superclass and then provides its own implementation. The method in the subclass must have the same name and parameters as the one in the superclass. Finally, method overriding supports polymorphism. Coming to this example, parent is the superclass and child is the subclass. As from this definition, a method in a subclass with the same name as a method in its superclass and also having the parameters as the one in the superclass. Subclass child inherits from parent class and overrides the display method to print child class display instead of parent class display. When you call this child as display, the display method of child method is executed printing child class display as output. Now that we have covered method overriding, let's move on to method overloading. Method overloading is also a feature in object-oriented programming that allows a class to have multiple methods with the same name but different parameters. Coming to the example explanation, the example class is defined with a method named add. This add method takes three parameters a, b and c, where the parameter c has a default value of 0. In the next line, we are performing the addition and returning it. An instance of the example class is created and assigned to the variable object. Calling this add method with three arguments will print 60 as output, and calling the add method with two arguments will print the output 30. This example demonstrates how method overloading works, where this example class have multiple methods of add with different parameters. Here there are three parameters and here there are two parameters. Let's take a look at what we have learned until now. Let's get started with what is file handling. File handling refers to the process of creating, opening, reading, writing, and closing files in a program. File handling in Python is really important because it lets you to save and manage your data efficiently. Files can store various types of data such as text or numbers permanently. Now that we know what file handling is, the first step to use it is opening a file. Let's see how it is done. To open a file in Python, we use the open function. The open function is a Python built-in function used to open a file. It takes two main arguments, the file name and the mode in which you want to open the file. This is the name of the file you want to open. It can also include the file path if the file is not in the same directory as your script. Next, mode. This mode specifies the operation you want to perform on the file. The result of this open function is a file object which is assigned to the variable file. The file object can be used to perform various operations like reading, writing, or closing the file. Before we move ahead, let's take a closer look at few common file modes available in Python. Python provides several modes to work with files, and here are the most commonly used ones. R represents read mode, which is used to open the file for reading. W represents write mode, which opens the file for writing or overwriting any existing content. A represents append mode, which opens the file to add new data without removing the existing content. Finally, R plus, which represent read and write mode, which opens the file for both reading and writing. Let's see examples for each different file modes which we discussed. This is an example of opening a file for reading. Here example.txt represents the file to be opened and R represents the mode specifying that the file is opened for reading. And here are the other examples of opening a file for writing, appending, read and write. Now that we know the modes, let's explore how to actually read content from a file. When a file is opened in read mode, its contents becomes accessible to read. Coming to the example, we use open function to open a file which takes two arguments, that is file name and mode. Here R indicates that the file is opened in read mode. This means you can only read data from this file, and if the file does not exist, an error will be raised. As we have already discussed, the file object returned by the open function is stored in the variable file, where this object provides methods and attributes to interact with the file's content. In the next line, file.read method reads the entire content of the file as a single string. If the file is very large, this could consume a lot of memory. For large files, it's better to read the file in line by line or in chunks. The content read from the file is stored in the variable content. This variable now contains the complete text from this example.txt. In the next line, we are printing the entire content of the file. Lastly, this file.close method closes the file. It is important to close a file after you are done with it to free up system resources and avoid potential data corruption. In simple words, we can tell in the first line we are opening the file, in the second line we are reading the entire content of the file, in the third line we are printing the content, and finally closing the file. This is how we read a file using read mode. Next, let's see how we can write data into a file. Writing data to a file is simple in Python. Depending on your needs, you can use the write mode to overwrite the content, or to add new data to the existing content, you can use append mode. Let's take a look at these examples on how we can write new data and overwrite existing content. In the first line, we are using open function which takes two main arguments, file name and mode. In this case, writing mode, that is W. In the next line, we are using file.write method which is used to write a string to the file. In this case, hello world is the string that will be written in the file. In the last line, we are closing the file using the file.close method which ensures that all data is properly saved and free up the system resources. Next, to open new data to the file, first we use open method or open function to open the file using the mode A, which indicates append mode. In the next line, as I have already said, file.write method is used to write a string to the file. Here /n, this is a new line, is the string that will be written to the file. The /n character adds a new line before the text, ensuring that the new line is added on the new line rather than continuing on the same line. Lastly, it's important to close the file to ensure that all data is properly saved and to free up resources. Now, as we are adding or modifying files, it is important to remember last step, that is closing the file. Let's see why that matters. Closing a file after you are done with it is very important because when you open a file, that file use system resources like memory and file handles. By closing the files, frees these resources, making them available for other processes and ensuring your program run efficiently. Closing a file also ensures that all data is properly written to the disk, preventing data loss or corruption. So always make it a habit to close your files after working with them to free up system resources. To close the file, you can use file.close method. Alternatively, you can use the with statement to ensure files are automatically closed. This with statement automatically takes care of closing the file once the block of code is executed, even if an error occurs. This ensures that resources are properly managed and makes your code cleaner and safer. The basic syntax for the with statement is as follows. It starts with keyword followed by open expression, next as, and the variable which contains the result of this expression. Next, this indented block of code uses the opened resources. Once this block is executed, it is automatically closed. In this example, we are reading the file, and in this example, we are writing the file. With this, we have covered the essential steps in file handling. Next, let's learn about the importance of file handling. And if you find this video helpful, don't forget to like, share and subscribe to this channel. File handling is a fundamental skill for any programmer. Let's know its use and importance in the following points. First, file handling allows us to save data permanently, unlike variables that are stored temporarily in a memory and lost when program terminates or ends. But files keep our data safe and ready to use whenever we need it. Second, files make it easy to share data in different parts of our program or different programs. It can be through different formats like CSV, JSON or XML files, ensuring smooth data transfer and compatibility. Third, managing large data sets in memory can be challenging. Files help us handle and organize large amount of data efficiently, making tasks like data analysis and machine learning more manageable. And this is also very crucial for applications that need to store data, settings, logs and more. Fourth, files are great for logging and monitoring events. They store logs of what happens in our program, which is super useful for debugging and keeping track of events. Lastly, files help us store configuration settings. Instead of hard coding settings within the program, we can save them externally. This makes our program more flexible and easier to maintain. Before we go any further in the video, if you are new to this channel, our channel is offering a free Python course to help you master programming. Your support means a lot to us. Please consider subscribing and hitting the like button. Also, make sure to share our videos in your college groups and with your friends. Let's make learning Python accessible to all. Coming to the video, we are going to learn about one of the most powerful libraries for data analysis, that is Pandas. First things first, let's know what is Pandas. Pandas is a open source Python library widely used for data analysis and data manipulation. Whether you are handling spreadsheets, time series data, or even large data sets, Pandas makes data manipulation and analysis very easy. Pandas provide high performance and tools to clean, analyze, and visualize data with ease. Next, let's learn how to install and import Pandas. To get started with Pandas, you need to install it using the simple command pip install pandas, where this command will download and install the pandas package along with its dependencies it required. Coming to importing pandas, we commonly import pandas in the form of alias as pd. This alias make your code cleaner and saves time. Just imagine writing pandas as 100 times in a code. It will be hard, right? That's why in place of pandas, we use alias, that is pd. Moving on, let's learn about data structures in pandas. Pandas basically revolve around two key data structures, series and data frame. Series and data frame are the cornerstone for data manipulation and analysis in Python. With series, you can get a powerful one-dimensional array-like data structure that can hold data of any type like integers, strings, float point numbers, etc. And it is perfect for handling single column of data. It is similar to a column in Excel spreadsheet or a single column in a database table. On the other hand, data frame offer a two-dimensional table allowing you to work with multiple columns similar to a spreadsheet. It is like a table with rows and columns. These structures provide a wide range of functionalities from easy data cleaning and transformation. By mastering these tools, you can handle complex data tasks with simplicity and elegance, making data analysis more efficient and powerful. Next up, creating a data frame. As I have already said, a data frame in Pandas is similar to a table in relational database or Excel. Creating a data frame is very simple. You can create it from various data structures like list, arrays, dictionaries, CSV files, Excel files, or even SQL databases. The first step in creating a data frame is importing pandas by using import pandas as pd. Next, we will create a dictionary. You can also take various data structures as I mentioned like list, arrays, CSV files, Excel files and SQL databases. Coming to this example, we created a dictionary where the key represent column names and the values are lists containing data for these columns. In the next line, we use pd.dataframe function to convert our dictionary into a data frame. In the last line, let's print the data frame to see our data organized in a tabular format. Here is how the output looks like, where the keys, product name and sales are the column names and these values are lists containing data for these columns. That's it, we have successfully created a data frame from a dictionary in just a few simple steps. For a quick revision in creating a data frame, first you need to import pandas, next you need to create a data directory, next create the data frame, lastly display the data frame. Moving on, let's learn how to read data from files. Reading data from files is a fundamental skill for any data scientist or analyst as it allows you to easily import and work from different datasets. As we all know, data often comes in various file formats like CSVs, Excel sheets or JSONs. Pandas can read them all. To read data from files, first make sure you have pandas installed and you need to import using import pandas as pd. Next, you can specify the file you want to read, like CSV, Excel, and JSON. First, let's read one of the most common formats for storing data, that is CSV. This will load the CSV file into the data frame df. This read underscore CSV function helps you to specify the CSV file name and can handle many variations of CSV files. This is how we read CSV files. It is also similar for Excel and JSON files. You need to just replace read CSV into read Excel or JSON with your file names, and you will be ready to analyze your data in Excel and JSON. Next, let's learn about basic data frame operations. Let's take a look at most commonly used operations. To perform these operations, first you should have created a data frame. To get a quick look at your data frame, we can use head method to view first 5 rows. By running print df.head method, you can display the first 5 rows of your data frame. Next, to get information about the data frame, you can use the info method to get a summary of your data frame, including the number of entities, column names, and data types. By running this line, you can get information about the data frame. Lastly, for getting statistical summary, you can use this describe method, which will return mean, median, mode, min, max, etc. of the data frame. By running this line, you can display statistical summary. Coming up, let's learn how to handle missing value or missing data. Missing data can be a nightmare for analytics and is a common problem when working with the real world dataset, and it is crucial to know how to handle it effectively. To do that, the first thing is to identify where the missing data is. You can use isNull method to see where the values are missing. This isNull method returns a data frame of the same shape with true indicating missing values. Also, you can use .sum method along with isNull method to get a quick summary of the missing data. This will give you the count of missing values of each column. Next approach for handle missing data is to fill missing data. For that, we use fill NA method. This method will replace the missing values with 0. Lastly, to handle missing data is to drop the rows or columns that contains them using the drop NA method. By mastering these techniques, you can ensure your data is clean and ready for analysis. Moving on, let's learn how to access columns and rows. Accessing rows and columns is fundamental for data manipulation and analysis. To access a single column, you can use the column name as key, which is similar to accessing a value in dictionary. To access multiple columns, you can provide multiple column names. To access rows, Pandas offer two primary methods for selecting data from a data frame. They are ILOC and LOC, where this ILOC is used for integer based indexing, meaning it selects data by the row position. On the other hand, LOC is used for label based indexing, meaning it selects data by row labels. This is the syntax for ILOC, which accesses the first row, and it is used when you need to access data by specific positions like in a list. This is the syntax for LOC. This is used when you need to access data by specific labels like in a dictionary. I hope this gives you the basic difference and when to use them. Next, we will learn about how to modify data in data frames. Modifying data is essential for cleaning, updating, and transferring dataset to meet specific needs. If you want to add a new column profit, you can add it by subtracting the cost column from sales. With this, the new profit column will be created. Instead of this, without doing any calculations also, you can simply assign a list or a series to a new column name. This also will create a new column. Coming to updating a value, you can update values of an existing column by using assignment operator. By executing this code, for the product name A, the sales will be updated to 120. Lastly, let's know how to save data. Saving data is essential as it allows you to preserve your changes for future use or sharing. The most common format for saving data is CSV. You can save data frame to a CSV file using the toCSV method. The index equals to false parameter ensures that the row index is not saved to the file. This will be the same for Excel JSON also. In place of toCSV, you need to mention to Excel or to JSON, and output file also you need to change to XLSX or JSON. NumPy, which is an essential library for data science and scientific computing. Without wasting time, let's get started. First, we will begin with knowing what exactly is NumPy. NumPy in short stands for Numerical Python, which is a powerful library specifically designed for numerical and scientific computing in Python. Its key features include multi-dimensional arrays or n-dimensional arrays that supports a variety of data types, making it efficient for handling large data sets. Additionally, NumPy is highly efficient and fast compared to pure Python list. And also, NumPy serves as a foundation for many other scientific and data manipulation libraries in Python, such as Pandas, Scientific Python, TensorFlow, and Matplotlib, facilitating seamless data analysis and visualization workflows. NumPy supports a wide range of linear algebra operations and mathematical functions that can be applied to arrays and matrices. To tell in simple words, the reason we use NumPy is because of its performance, simplicity, and a large active community. From data science and machine learning to scientific research, NumPy is used in variety of fields. Let's move on to its installing and importing. First, we will start with installing NumPy using pip, which is the package installer for Python. Before executing this command, make sure you have Python installed in your system. After that, open your command prompt or terminal and type this command pip install NumPy. This command will download and install the latest version of NumPy from the Python package index. Once the installation is complete, you are ready to import and start exploring its powerful features. To import NumPy in your Python code, we can use import NumPy as NP. This statement imports the NumPy library and assigns it in the alias NP. Using an alias like NP will make your code simpler. Instead of typing NumPy every time, when you want to use a function from the library, you can simply use NP. Now that we have seen how to install and import NumPy, let's look at how to create NumPy arrays. Arrays are the core components of NumPy. To create an array, we use np.array function. This is an example how we create an array using np.array function. By executing this code, creates a one-dimensional array which is straightforward and easy to understand. NumPy supports various types of arrays like one-dimensional array, two-dimensional array, multi-dimensional array. These arrays are highly efficient and form the backbone of NumPy functionalities. Next, let's see basic array operations. Arrays in NumPy comes with powerful operations. For example, array arithmetic and array slicing. These operations make data manipulation very easy. So let's explore these. First, array arithmetic. NumPy allows you to perform element-wise operations on arrays efficiently. Some common arithmetic operations you can perform on NumPy are addition, subtraction, multiplication, division, modulus, and power. Let's see how addition works. First, you need to import NumPy. After that, you need to create a couple of arrays to perform addition. Here we have two one-dimensional arrays, array 1 and array 2. As I have already said, NumPy allows you to add these arrays element-wise very easily. As you can see, the corresponding elements of the array are added together. The result is a new array where each element is the sum of the elements at the same position in the original array. Next, let's see how array slicing works. Array slicing in NumPy is a way to access a subset of elements from an array. It is a powerful feature that allows you to extract specific parts of an array without modifying the original array. Let's see in this example how it is done. For the first step, we import NumPy as NP, and in the second step, we create an array using np.array. You can slice arrays using the colon operator. The general syntax for slicing is array in brackets, start index and stop index, in between colon operator is present. If you run this code, as we know the index starts from 0. Here we are performing slice operation in between start index 1, that is here, and 3. As we already know, 3 is excluded from the stop. So the output will print 20 and 30, which is part of this original array, and slicing will not create new arrays. Before we go any further in the video, if you are new to this channel, our channel is offering a free Python course to help you master programming. Your support means a lot to us. Please consider subscribing and hitting the like button. Also, make sure to share our videos in your college groups and with your friends. Let's make learning Python accessible to all. Coming to the video, let's talk about array attributes. Every NumPy array has attributes that provide crucial information. For example, shape gives the dimension of the array, size tells us the total number of elements, and dtype reveals the data type stored in the array. For example, if we print array.shape, it will show the dimensions of our array. Likewise, if we print size and dtype, it will show us the size and data type stored in the array. These attributes help us understand the structure and properties of our NumPy array, making it easier to work with them efficiently. Moving on, let's learn about mathematical operations. NumPy provides a wide range of mathematical operations. These operations can be performed on an array of any dimension, making NumPy a fundamental tool for numerical computing in Python. NumPy simplifies both basic and advanced mathematical operations. For example, basic mathematical operations use functions like sum function, mean function, max function, or min function to find sum, mean, maximum, and minimum of an array. Advanced mathematical operations involve performing square root with np dot square of array or exponential function with np dot exponential of array. Next up, let's explore random number generation capabilities. Generating random numbers is another amazing feature of NumPy. For example, to generate random floats, you can use this. By executing this code, you will get a 2 by 3 array, meaning 2 rows and 3 columns filled with random float numbers. These float numbers are uniformly distributed in the range 0.0 to 1.0, and the shape of the array is determined by the tuple 2, 3. And to generate random integers, we use np.random.randint. By executing this code, generates a 3 by 3 array, meaning 3 rows and 3 columns filled with random integers. These integers are uniformly distributed in the range between 0 and 10. And the size parameter specifies the shape of the output array, which in this case 3, 3. These random number generation functions are useful for a variety of applications such as statistical analysis, testing, and simulations. Finally, let's discuss some real-world use cases. NumPy applications are vast and is essential for various fields. In machine learning, it pre-processes the data for analysis. In statistical analysis and data visualization, it calculates key statistics and integrate with visualization tools like Matplotlib. In physics and engineering, it aids in numerical simulations and solving complex problems. NumPy's versatility and performance make it crucial for scientific and analytical computing. To summarize, NumPy is a game changer for anyone working with data science, machine learning, or scientific computing. This is the end for our Python programming series. Hope you learned a lot. Don't forget to like, share, and subscribe.